Hello everyone and welcome to another tutorial on our channel Learn at No Star. In today's tutorial, we are going to be writing 10 SQL queries. They are going to be of different levels of complexity, so some of them will be intermediate. We'll start with intermediate and move on to more complex queries. We'll try to understand the step-by-step process behind writing these queries and the approach that we should be taking to solve complex SQL queries. So we'll try to understand all that and also how to build the logic of solving a SQL query. So let's get started. We are going to be working mostly with the employee database. The database details will be provided in the description below, so you can go ahead and create the tables and insert the data and work on that data. If any query seems familiar to you and you want to skip ahead to the next query, then the timeline is also provided in the description, so you can directly skip ahead to the next query. So we are going to be working with the employees table. The data is quite simple in the table. We have the employee ID, the full name, we have the department ID, we have the salary for the employee, the hire date, and the manager ID for that particular employee. Please just ignore the format of the full name. I created that for some other video tutorial that I was planning to make. So let's get started with the first query. So the first query that we are going to attempt is of intermediate level, and it is to find out the employees with the highest salary in a department. Now there are two approaches to this which we are going to discuss in this video. So what should be the first thought that comes in your mind when you are asked to write such a query? So as soon as you see the word highest, so it could be lowest, it could be highest. So anything that is related with ordering, then the first thing that should come in your mind is that you can be able to use the aggregate functions. By aggregate functions, we mean that we can use the rank function, row number function, anything that is the aggregate function which uses the over partition by clause and so on. Especially in a case where you are supposed to order within a category. So here if you are simply asked find the employees with the highest salary in the whole organization, then there's no grouping by needed, there is no category wise grouping that is needed. But as soon as you are asked to find out employees with the highest salary in a department, which means there would be an employee with the highest salary in each department. So if you have 10 departments, you need 10 different employees in the output. So as soon as something like this is asked, you should try to go for aggregate functions. Aggregate functions are especially going to be helpful if you are asked something like which is the nth highest salary, so the second highest salary or the third highest salary and so on. If you're just asked the highest or the lowest salary, there's another approach also that can be taken using a subquery, which we are going to discuss now. So we have to find out the employees with the highest salary, which means we have to find out the employees with the maximum salary in a department. So this is a very simple SQL query that we can write, which is simply select department ID and max salary from employees and group by on department ID. So if you execute this query, you will get the department-wise maximum salary. Now we said that we want to find out the employee who has got this salary. So we need to put this in a subquery. And what we need to do now is to join to the results of this subquery and get the desired output. So what I'm going to do is the main information that I want to fetch now is the employee ID or the employee who has got this salary. So I'm just going to say select employee ID. You can select the other details that you want. Salary from employees. Then I'm going to do an inner join. And we have to call it, let's say, employee 1 on. Let's give an alias to the employees table. So we are going to join on the department ID and the salary to fetch the employee ID. So employee dot department ID is equal to the department ID that is coming from the subquery. So employee 1 dot department ID, and the next join condition is going to be on the salary. So within this department 1, whichever employee has a salary of 100,000, fetch the employee ID for that employee. So I'm going to match on employee salary is equal to employee 1 dot max salary. So since I'm going to fetch this column, I have to give it a name. So I'm just going to give this as max salary over here. So now if I'm going to execute this, so now department ID is an ambiguous column. So I have to define it by the table name. So employee.department ID. And now if I execute this query, I'm going to get the employees from each department who have the maximum salary. So if you want to go back and check on this table, you can see that in Department 1, the highest salary is of employee ID 7. So if we go back over here, we can see that the highest salary is for employee ID 7 in Department 1. So this is one approach you can take to find out the maximum salary. Now the next approach, as I discussed, is using the aggregate functions, which makes it more easier to write. It's more neat and tidy. So we're going to see that approach now. So in this approach, so we can select the employee ID, we can select the department ID, and then you can create a rank function. So rank over. So we have to calculate it department wise. So partition by department ID and order by salary as, let's say, salary, and then simply from employees table. So if I just execute this much part of the query, you will see that for each salary in each department, there have been some ranking. So to see what exactly is the ranking, we can add the salary here as well. So if you see over here, you will see that the salary, this has been ordered in the ascending order, which is how it is ordered by default. And so the maximum salary has got the highest ordering. So we wanted the employees which have the highest salary. So what I'm going to do over here is I'm going to sort it in a descending order so that the highest salary will get the ranking of 1, and then I can just filter on that ranking. So once you have created this, there are two ways to go about it. You can either put this in a CTE or you can use this as a subquery. So for now, I'm going to just use it as a subquery just to show how this is going to work. In a separate video, we will discuss what is the difference between subquery and CTE, and when can you put a query as a CTE and when can you just treat it or leave it as a subquery. So for now, let's just say select. So you can go on and select the columns that you want. So you want the employee ID and the department ID, and maybe you also want to see the salary from, and put this as a subquery as employee. And now what we need to do is add a where clause, because we only want to select those employees for whom the rank is 1, because the rank 1 would be given to only those employees who have got the maximum salary. So where cell is equal to 1. So now if we execute this query, we are going to get the same results. So if we go back here, one is 100,000, 80,000, 85,000. And we have the same results over here. So you can see the difference in the first method and the second method. This is more neat while you're writing, so you can go for this approach as well. Let's move on to the second query that we are going to write. So the second query that we are going to attempt to write is to find out the employees with salary lesser than the department average. Now, as soon as I hear this question, we do not need to get confused. We're going to split it into parts. So what is the part? It says employees with salary lesser than the department average. So the very first part that I need to calculate is find out the department average. And then I can compare the salary of each employee with the average salary, and for whomever the salary is lesser, I can just output those employees. So again, this is very simple. We can actually take the same query that we just wrote to find out the maximum salary. So let's go back to that query. using this approach. Okay, and we can just manipulate this query a little bit and we should be good to get the results. So I am just going to open a new query window and copy this. So what we are going to do, the first part is to calculate the average salary. So this is going to be your first part and it has to be department wise. So this is my first part that I'm going to execute. So I'm going to write it separately for you first. So this is the first part. Now instead of maximum salary, we need the average salary. So average is simple. You can have the average AVG function that will calculate the average salary for you. It's going to be grouped by the department ID. If I just execute this query, I will get the average salary for each department. Now going back to the main query, this is the part that we just changed. Instead of the maximum salary, we made it average salary. So that is what I'm going to change over here as well. Now the second part is to select all those employees whose salary is less than this average salary. So the same query will hold good. We just need to inner join with the result of the subquery. The result of the subquery is the average salary of each department. So what we are going to do over here is the same joins, join on department ID, and then we are going to compare salary for each employee of that department. So I'm going to say the employee of salary is going to be less than the average salary. So now if we just execute this query, we should be getting all the employees whose salary is less than the average salary of their departments. So now let's move on to the third query that we are going to write. So the third query that we're going to write is to find out the employees with salary lesser than the department average but more than the average of any other departments. So again, let's try to split this into subparts. So the first part is employees with salary less than the department average. This is same as what we have written in the query above. So this part is going to remain the same. But there is another condition that has been added to this query which says but more than the average of any other department. So there are two where clauses that need to be included. The first part remains the same, so we can reuse the same query. We need to add one more where condition to this which says more than the average of any other department. So let's go back to our average salary that we just wrote. So this is the salary for the average. So these are all the employees whose salary is less than the average salary of the department. Now what we have been told is it should be more than the average of any of these other departments. So for that, let's add another and to the where clause. Now we have been told that the salary should be greater than the average of any other department. So the first part here is to find the average salaries of all those departments. So what I'm going to do is I'm just going to find the average salary of all the departments. So again, same query, average salary from employees group by department ID. So this is going to give me a list of values. So if I just execute this portion right now, I'm going to get three different values because there are three departments in my data. If there are more departments in your data, you'll get the values as other number of departments in your data. So this is a list of values. So this becomes something like an end clause. If I say and employee dot salary in any of these three values, then that is what it interprets to, and that is the result that I'm going to get. Any employee whose salary is equal to any of these three values. Okay, and as well as the first condition, the previous condition that we have already mentioned, has been satisfied as well. But my condition is that the employee salary here should be greater than any of these three values. So for that, there is a clause which can be used, which is any. So as soon as you write any over here, what happens is employee salary is greater than any of these three values. Okay, so if I execute this, I'm going to get just one employee whose salary is less than the average salary of his department, but it is greater than the average salary of any of the other departments. Okay, so let's just go back and execute this part once again. So what were the average salaries of the other departments? So one of the department has a salary 35833, which is less than the salary of this employee whose employee ID is 2, and hence the result. So this is the third query that we have written. Let's move on to the next query. So the next query is going to be to find out the employees with the same salary. Now again, if somebody asks me this question, there are two things that would come in my mind. So when we're saying employees with the same salary, which means that there has to be a comparison in the same table between the salaries of different employees. So I have to do the comparison with the same table, which means there could be something like a self join happening. So that is the first thing that would come to my mind. So maybe I can use a self join to come at this result. And the second thing that would come to my mind is maybe I can use either the lead or lag functions, because it is saying that employees with same salary, which means maybe if I order by the salary in the table, I would be able to compare with either with the previous row or with the next row, and then just calculate the difference maybe, and wherever the difference is 0, that would be the same salary. So there are two approaches that come in my mind. I'm going to discuss the first approach right now. So let's just do a select from the employees. Now, since we are going to make a comparison with the same table, I'm going to create two instances of this table. So for the first instance, I'm just going to say employee 1, and I'm going to do inner join with the second instance, which I'm going to say employee 2. So the main thing that you need to consider over here, okay, let's format this a little bit. So the main thing that we need to consider over here is the join condition. So since it is a self join and we are going to compare based on salary, so we said that they should have the same salary. So my first join condition has to be based on the salary, and I should be able to compare the salaries from the first instance to the second instance. So I'm just going to write employee 1 dot salary is equal to employee 2 dot salary. So I am just going to select the employee ID over here, and let's say also select the employee 1 dot salary. Okay. Now the important part is the second condition in this query. Now if I just say employee 1 salary is equal to employee 2 dot salary, let me just execute this query. So what I'm going to get is all the employee IDs from the table. And why has this happened is because it has compared the same employee as well. So I have created two instances of this table. Let's go back to our table. So this is our table. I have created two instances of this table, and I'm just saying where salary from the first instance is equal to the salary from the second instance. So it is able to find employee ID 1 in both instances, and that's why it compared the salary for employee ID 1 from the first instance to the salary of employee ID 1 from the second instance, which was equal, and therefore it resulted in the output and gave the result as employee ID 1 as well. Now this is not what we want. We do not want to compare the same employee, so that's where the second condition comes into picture. So what we're going to write over here is, and employee 1 dot employee ID is not equal to employee 2 dot employee ID. So if I just execute this, I'm going to get the actual two employees whose salaries are same, which is employee ID 10 and 11, who have got the same salaries. So if we check over here, this is employee 11 who has a salary of 11,500, and employee 10 who has the same salary of 11,500. So this is what we would be able to get, and this is how we need to frame the query. Okay, so the next query is find out the department where none of the employees has a salary greater than their manager's salary. So again, many parts to this. First is we have to find out the employee's manager. We have to find out the salary of the employee's manager, and then we have to compare it with the employee's salary. So let's start framing the query and then we'll look at the different steps involved. So now let's try to attempt the first step, which is comparing the employee salary with the manager's salary. So how can you identify the manager's salary? Again, because you're comparing within the same table, the concept of self-join kicks in, and you have to make two instances of the same table and do a comparison to fetch the employee salary and the corresponding manager's salary. So to do that, again, creating two instances, we have the employee one instance, and we are going to do an inner join again on the same table employees, and let's call it manager. So that becomes easier for us to understand. So we can actually move this one over here. So what we're going to do is the employee for the first instance, we are going to fetch the manager ID. So for employee ID 1, I'm going to fetch the manager ID, which is 3. So what I'm saying here is employee dot, okay, let's see the manager ID. Manager ID is equal to the second instance, manager dot employee ID. Okay, so what I have done is I have in step 1, I fetched the manager ID for employee ID 1. Then I'm doing a join on this manager ID. So I'm going to search for this manager ID in the employee ID column. So I'm going to search for 3 in the employee ID column, which is going to take me to this particular record. Okay, and then I'm going to fetch the salary from this instance for the manager and from the previous instance for the employee. So now I got the salaries for the employee and the manager. So here comes my comparison. So I'm going to add a where clause where employee salary, employee dot salary is greater than the manager's salary. Now, why have I done this? This is because as soon as you see a question where the ask is that none of the employees or no employees, so anything like that, where you're supposed to check that none of a list of values. So the easiest way to handle these scenarios is to first find out all the departments where there are employees whose salary is greater than the manager. And then I'm going to take the remaining set of department IDs because it is easier to compare row by row rather than going in a loop and comparing. Okay, so that would become very complicated. So what we can do for all these negative kind of scenarios is that first find out where the condition that we are being asked is true or the opposite condition is true, and then select the remaining set for that condition. So I'm going to find out the departments where the employees have salary, where any of the employees has salary greater than the manager's salary, and then I'm going to just subtract those departments from the complete list of departments. So to do that, this is where my condition will be satisfied. So I just need to go to the right database. So if I execute this query, I will get one employee whose salary is greater than the manager's employee. So the employee's salary is 85,000, whereas his manager is with the employee ID 5, whose salary is only 80,000. So now there's this one department, and this department, the employees department, is department 3. So now, which means that department 1 and 2 have no employees whose salaries are greater than the manager's salary. So that is what I need to select now. So I'm just going to select the department ID from here. I'm going to say select distinct department ID from employees where department ID not in the output from this particular query. Okay. Select distinct department ID from employees ID is going to give me all the departments that we have, 1, 2, and 3. So adding the alias name over here to avoid the ambiguity, and now executing this query would give us the correct result, and the department IDs 1 and 2 are the ones that we need. So now moving on to the next query, which is much more simpler than it sounds, and it is simply to find out the difference between the employee salary and the average salary of the department. So here there are only two steps. First is to find out the average salary of the department and then subtract it from the salary. So let's write this query. So what you can do is simply write it as a single statement query. So what you can do is just reference to the salary of the employee and then use the average function to calculate the average salary, and then use the power of the aggregate functions to calculate the average salary within the department for that particular row. So over partition by department ID, and you can give a alias or a column name for this, and you can simply execute this query. So this is a very simple one line query that can be written. So here you can see that the differences sometimes are in negative as well. So if you want to calculate this, if you want to show the employee ID and their salary as well, maybe department ID as well, select the average salary as well, execute. So you will see that the average salary for this is 63,750 and 35,000. So if you subtract this, this is what you are going to get. So this is going to be a difference in salary. So the idea of solving this query is to show you that it can be done simply as a single statement. You do not need to perform any joins on the department ID by creating a subquery. So this makes it very simple if you use the aggregate functions over here, because it is going to calculate an average for the department ID, which is referencing to that particular row that you are dealing with. Okay, so this can be written simply as a single line query, which makes the aggregate functions again very powerful. It is employees whose salary is in top 2 percentile in the department. So the function that we're going to use to calculate the percentile is called the percent rank function. Let's just write a simple query using that function and see what is the output from that function. So I'm just going to leave this over here. What I'm going to do is remove this difference in salary, and now here I'm going to use a percent rank function, and as in a rank function you do not need to define any column over here. You have to define your partitioning. So we can partition by the department ID. We need to order by, because we are saying that the salary should be in the top 2 percentile. So you have to order by the salary column, and let's just order in a descending manner so that the maximum salary will come at the top. And let's just call it rank. And this is the output that we get if we execute this query. So let's go to department 1. This is department 1, and we see that the rank which is given to the highest salary is 0, and the rank which is given to the lowest salary is 1. So if we do like this, then the lowest salary will get the highest rank. That is not what we want for now. So let's take off this descending portion from here and now execute this query. So if you execute this now, you will see that the highest salary is going to get a percentile of 1. Now what is our requirement is to find all those employees whose salary is greater than the or is in the top 2 percentile. So I'm going to first create this as a subquery and write a query on top of that. So select employee ID, salary from, and this will be our subquery as employee. And now I need to add a where clause to select only the top 2 percentile. Rank is greater than equal to 0.98. So that will give me all 0.98 till 1. Okay, that is my 2 percentile. So now if I execute this query, I'm going to get some results which are going to give me the topmost employees, topmost 2 percentile employees in terms of the salary in each department. So this is just to make you aware of how the percent rank function is available as part of the aggregate queries and can be used to solve such kind of scenarios. Now let's move on to another query. And this query asks us to identify employees who earn more than every employee in department number 2. Again, let's split it into subparts. So what we are saying over here is employees who earn more than every employee in department number 2. So the first step is to find out the salary of every employee in department number 2. Okay, which would give us a list of values, obviously, because there would be, if there are more than one employee in the department, it would give us a list of values. Okay, and then we just need to make a comparison with the current row employee and just compare the salary of that employee with all that list of value that we have got over here. So let's go step by step again. So first what we need to calculate is the salary of every employee in department number 2. So select salary from employees where department ID equal to 2. So here by department number, we are referencing to department ID column in our table. Okay, so now if we execute this query, we will get the employees. There are 3 employees and department ID 2, and we've got the salary of each of those employees. Now what we are saying is select all those employees from employees table where salary of the employee is greater than the salary of all the employees in department 2. There's other useful clause that can be used. Now, in one of our previous queries, we saw the any clause where we said that the employee salary should be greater than the average of any of the departments. So in this case, instead of saying any of these salaries, we are saying that the salary should be greater than the salary of all the employees of this department. So what you can use over here is simply greater than all. So if I execute this query, I'm going to get employees, and let's just go and see the salary for these employees, and their salaries are 85,000 and 100,000, and which are greater than the salary of the employees for department number 2. So if I just go back and check the employees, the salary for the employees for department ID 2, you will see that the salary that we have got for those employee IDs are salaries which are greater than each of these salaries. So this is one way of calculating it. Obviously, there's another way in which we can calculate, because this can be simplified and this can be interpreted as saying, when you're saying that your value should be greater than a list of value, then all the values in that list, basically what you are saying in other words is that your value should be greater than the maximum value in that list. So if your value is greater than the maximum value of in this list, so the maximum value in this list is 80,000. If your value is greater than 80,000, which by default makes it greater than any of the other values in the list, because 80,000 is the greatest value in that list. Okay, so when you have numeric values where you can actually go and calculate the maximum, then what you can do is simply you can calculate the maximum salary for department ID 2, and you can write a very simple straightforward query and you would still get the same result. Okay, so now we are going to move on to more complex queries. Complex in terms of they have different subparts, so they have lots of conditions that need to be evaluated. Even the most complicated queries would be just sounding complex because there are a lot of conditions which need to be evaluated. They might also need the use of CTEs, subqueries, and also sometimes complicated joins. But if you are able to split those queries into small parts and then try to approach those small parts and solve those small parts and then put it all together, it would be easier to write the complex query as well. Okay, now let's move on to this query. So this one says that find out all the department names also with their employee names with more than 2 employees. So all the departments with more than 2 employees, and the salaries of those 2 employees should be greater than 90% of the respective department average salary. The first thing that comes in my mind is to have a count and then use a having clause, obviously. So having that count star or whatever count column is greater than more than 2, right? So greater than 2 should be fulfilling this criteria. Instead of and here we should be writing whose. So with more than 2 employees, whose salary is greater than 90% of the respective department average salary. So let's write this query and see how we can approach it part by part. So there are different parts to this query. The first part asks us about finding out the average salary for the department, and then we need to make sure that there are at least 2 employees in that department whose salary is greater than 90% of that average salary that we just calculated. So step one is going to be calculating the average salary of the department. Then we need to make a comparison where we are going to compare the salary of the employee with the average salary of his department. And if his salary is greater than 90% of the average salary, then we are going to count those employees and the count should be more than 2. So this is a conditional count that is going to happen because we are only going to count those employees whose salary is greater than 90% of the average salary. So we'll also see when writing this query how a conditional count can be implemented in SQL. So let's get started. So the first step is going to be calculating the average salary of the department. Now we are going to compare in the next step this average salary with the salary of each employee. So the approach I'm going to take to calculate the average salary is going to be using the Windows function so that I have an average salary calculated just across each row. Okay, what that means is that I will have all the employee records and the average salary of the department just included as a column for that row. So we already have the employee ID and salary. So the next part that I'm going to calculate is the average salary for each department, which can simply be calculated by using the average function. I'm just going to use the over clause over here, partition by department ID, because we want to calculate it for each department as, let's say, average salary. So now if I execute this, I'm going to get the employee ID, his salary, and the average salary for his department. So to make it more clear, maybe we can include department ID as well in the query. So for this department, the average salary is 63750. So that solves the first part of a query to find out the average salary by each department. Now we need to make a comparison. We need to compare the salary of the employee with this average salary that we just calculated. If it is 90% of this salary, then we have to count that employee and there should be at least 2 employees of this kind for that department. So let's put it as a subquery, and what I'm going to do now is select, let's say, employee ID, department ID from this query that we just created. Now to this query, we are going to add a conditional count statement. The conditional count can be implemented by using the case statement first of all. So let's first write a simple case statement, which is just going to check the salary of the employee. So when salary is greater than the average salary, then we are going to set it to 1, else we are going to set it to 0. And okay, now what we're going to do on top of this is we are going to calculate a sum. So every time an employee salary is greater than 90% of the average salary of the department, the counter is going to be set to 1 as per this case condition that we have written. And so we are going to keep on counting those employees by just summing up those ones. So if there are 2 employees, the sum would be 2. If there are 3 employees, the sum would be 3, and so on. So I'm going to calculate this sum. Now we have to make sure that we are calculating this sum for each department. So again, I'm going to use that over condition, and I'm going to write partition by department ID as employee count. Now we have to count those employees whose salary is greater than 90% of the average salary. So we are going to multiply this average salary over here by 0.9. So now if I execute this query, so here we have got the employee count. So these are the employees number of employees whose salary is greater than 90% of the average salary in the department. So we see the employee count is 2 for 2 departments and 1 for the other department. So let's change our problem statement a little bit and consider those departments where there are at least 2 employees whose salary is greater than 90% of the average salary of the department. So now if you look at the result set, you will see that the result set is per row. We just need the final result set. We just need those department IDs now. So what I'm going to do is put this as another subquery. So this becomes a subquery within a subquery, and employee 1. And now I'm going to select the columns or just the department ID from this query. Okay, we already have the bracket. Now another thing that I need to do is to add that where clause. So where the employee count has to be greater than or equal to 2. So now if I execute this query, I'm just going to get those departments for which the employee count is greater than or equal to 2. Again, we see that this is per row. So what I'm going to do now is add a distinct over here, and that should serve the purpose and give us the desired results. So this is how this question can be attempted. Again, splitting the problem statement into smaller parts and then calculating everything. Now we talked about conditional sum. So this is how or conditional count, this is how it can be achieved. This case statement, you can just set a value of 1 for whatever criteria you are checking for that row, and then do a sum on all the rows which have satisfied the criteria, and then use that count in your where clause or having clause. So moving on to the next and the last query, and this query has also been asked in the data analytics interviews for some of the big firms. So the query is select top 3 departments with at least 2 employees and rank them according to the percentage of the employees making over 100K in salary. So again, splitting this query into subparts. So the easy part is to calculate the departments which have at least 2 employees. So we just need to do a count of employees in the department and check that it is greater than or equal to 2. Then the next part is to calculate the percentage of the employees making over 100K in salary. So first we need to do a conditional count of the employees whose salary is greater than 100K. Then on that conditional count, we need to calculate a percentage. So conditional count divided by the total number of employees in the department is going to give us that percentage. So that is the second part that we need to do. And then we need to find out top 3 departments in this way. So based on this percentage of the employees that we just will get from this part of the query, we have to order by this percentage of the employee and select the top 3 departments. So let's get started with writing the query. Okay, so let's start with the most simple part, which is to calculate the count of employees in each department. So this is simply going to be count of employee ID from employees and group by department ID. So we can also select department ID. So if we execute this query, we will get a count for each of the department. So we wanted the departments. So we wanted to select the departments where there are at least 2 employees. So now I'm just going to remove this count part from here. And instead of calculating it here, I am just going to use a having clause. Having count star is greater than equal to 2. So if we execute this, we can see that all our departments are fulfilling this criteria. So that's why we have got all these 3 departments in our output. So now let's go about addressing the second subpart of this query, which is to find out if the employees make over 100K in salary. So here there's a comparison that is happening. I want to find the salary is greater than equal to 100,000. It says over 100K for our data. We just have 100K is the maximum that we have. So let's make it greater than equal to 100K. So obviously this is not the way you have to write it. So you have to use a case statement. Case when salary is greater than equal to this thing 100K, then 1 else 0 and okay, so now we have written that statement that will give us 1 or 0 depending on whether the employee's salary is greater than equal to 100K or not. But the problem statement is asking us to calculate a percentage of this employee. So how can you calculate the percentage in this department? By dividing this. Okay, first of all, you will need to sum it. Okay, you will need to do a sum of this. So this will give you the total number of employees in the department whose salary is greater than 100K. Now to calculate that percentage, we have to divide it, and we have to divide it by the count of the employees in that department. So count of employee ID as, let's say, percentage. So now let's just execute this query. So you will see. So now what you would see is that the result is 0. It is not the decimal value that we expected. This is because when you use the division operator in SQL, it is only going to return the integer part. So to fix that, what we can do in this is just to multiply this by 100 over here. And this should give us the result in terms of percentage. So this is 25% of employees in department ID 1 have salaries greater than 100K. So now going back to a problem statement, we have solved 2 parts. We have calculated the percentage of the employees. We have identified the departments which have at least 2 employees. Now we need to order by this percentage that we just calculated. So going back to our query, what we are going to do is add an order by clause. Now, since I want to refer to this calculation that I have done as a second column in this query, what I'm going to do is just refer to this calculation by the column position in the query. So this is the second column position in which I have made this calculation. So this is the second column in my select statement. So if I just do order by 2 and I describe the direction as descending and now execute the query, I will get the output sorted in the right order. So this is how you can just refer to the column that you have performed a calculation on in the select query by the number at which the calculation has been performed in that column. Okay. Now we needed to select top 3%. You can see that we have only 3 departments. So let's just select the top 1 department or top 2 department. So what we can do is just add a top 2 over here. And if I execute this, we will be getting only the top 2 departments. Now the both of the department 2 and 3 had 0 values. So it has randomly picked up any of those values, and that's how it has calculated. Now let's go back to our data. And since we are already done with the other queries, let's actually go update the value of salary in one of the departments. So let's update this for employee 5. So I'm just going to write an update query over here. Update employees, set salary equal to 110K, where employee ID equal to, let's say, 5. So I'm going to run this query. I'm going to update it for department so that we can have more realistic results. And let's look at the data now. And I'm also going to change the percentage. So for department 1, I'm going to update the salary of employee ID 3. And for him also, I'm going to make it, let's make it 110K. Okay, so now we have some data where we have different percentages of employees having that. So now let's try to execute this query, and you will see that your results are 1 and 2. Department number 1 had 50% of the employees whose salary was greater than 100K, and department ID had 33% of the employees whose salary was greater than 100K. So this is how simply this query can be written. So though the problem statement sounded confusing and complicated and long, but if you just split it into parts, try to solve one part at a time, the query writing will become easy. So this is my way of approaching complex queries. I hope that you found the video useful. All the material related to this video is provided in the link in the description below, so you can go check it out. If you think that this video has helped you in writing complex queries, then please do subscribe to our YouTube channel, and also please comment, like, and share this video, and also let us know what topics you would like to see in the future videos. Thanks a lot for watching. Have a good day. Bye-bye.